How did you find the EMBL on your first impression? I mean, did you have an idea, or was it, all new to you?
I was like, wow, what is this place? I definitely got this impression. It was a mixture of so many different technologies and so many different minds and fields and buildings. And it was like stepping into a living map of different roads and alleys, and you could choose whatever you want and ask any question you want. It felt like fantasy. Of course, I had to catch up with a lot of the science that's going on, but I quickly felt integrated.
I was wondering, I mean, you mentioned that your background and specialization at that point was medicinal chemistry, and I don't recall the EMBL having a lot of medicinal chemistry. So how did it work? I mean, did you find a project that was related to that? Did you go in a different direction?
Where I was more active in was synthesis, building essays for activity or for inhibition. But also I tapped into the computational world a little bit because I got very much interested in how computational chemistry can aid and can speed up drug discovery and drug design. So I decided to take this substrate not only as the starting point for my synthesis, but also as the starting point. I wanted to take it as a query in a computational software to see what other compounds are actually similar to that natural product that we can use against this phosphatase.
So I know now a lot of this is done with artificial intelligence, and you basically going to explore all the possible physical space, even of things that are not existing anymore. Was it something that happened also back then, or you did it with more traditional methods?
I don't think so much AI was involved back then, more like softwares that used very large libraries and then a lot of chemical human eye to look at these results to identify things that don't make sense because the computer makes a lot of errors, to cluster those in specific core structures to try and we had to do so many filters with the human eye. So also adding filters such as, is this molecule possible to even synthesize? Is this molecule possible to, for example, do we have a handle on this molecule where we could attach some lipid tails, for example, because we know that the lipid tails are crucial for binding of this phosphatase to the substrate. Things like that. And then you pick and you go to the lab and you try to do that. And then there's another
Iteration.
and another iteration, exactly. And during that time, you have to be ready for things not working. And it was very interesting, my time in EMBL as a chemist, because, especially in the beginning, because everyone around was generating this crazy amount of data because they're using these machines that generate this crazy amount of data, like sequencing and proteomics and transcriptomics. And, with one single essay, you can generate a lot of data that you can look at. And I remember I spent almost 5 months to try to alkylate one alcohol, which did not want to be alkylated. And sometimes I'd alkylate it, and then the protecting groups on the other alcohols, which I protected so that they are not alkylated, would actually dance around the molecule, and then I would end up alkylating the wrong alcohol. So it was really like chasing that bond.
So I was wondering whether being in an environment where you have lots of different disciplines all in the same lab, led to even more interaction with people. I mean, do you value this network? Is this a network that you're still using in your work?
A lot.
Okay.
A lot. This was, I think this is one of the biggest things I've inherited. I think when I came here, I was prone to learning interdisciplinarity. I guess by nature, I was. I've always tried to answer a question, for example, using different opinions and different expertise. And being a sociable person, this made it easier to learn about more ideas and engage in different conversations, etc. But being in EMBL in general and in the current lab in particular endowed me with a bold sense of interdisciplinarity that I took with me with confidence. I developed sort of a habit of bridging fields, bridging collaborations, bridging the let's say the right people from different groups, and of course I took that with me. This passed on in my work at in industry and in biotech, and I would say I'm still very interdisciplinary, maybe more than ever before, and I definitely use this in my daily work, whether it's on a scientific project level, whether it's on my, let's say, generalist approach level, or communication level, leadership even. I think interdisciplinarity is what propelled me into leadership at a very early stage in my career. People ask me what is the difference between academia and industry. I would say in academia, you can have 1, 2, 3 different kinds of careers, like staff scientist, professor, associate. But in industry, you can have 40 different careers because that space is much bigger. A lot of you get into the nitty-gritty details of regulatory, CMC, medical affairs. There's a huge world of clinical development out there. There's just so many different roles only in that area. And so the world there is really big. And of course, sometimes you would think, okay, but that's not exactly early research, but it depends on how you see it, really. If you see it as, I'm not in the lab anymore and I'm not doing this specific thing, which I would like to do every day for I don't know how long. And there's another way of seeing it. This little thing actually led to something bigger, and there's just a huge construction site out there to try and make this little promising thing something tangible in the real world.